Hi, I'm Ms. Matsuoka, and I'm going to show you about how to solve work problems. These are really mainly word problems that are rational expressions. So we have this problem, we have Jack and Jill, together they can solve 40 problems in an hour. Jill can solve 6 problems in 15 minutes, so how much time does Jack need to solve 8 problems? So the first thing that you're really doing is you're using this formula like R equals J over T. And so if you're not familiar with this, this is where it comes from. It comes from J is equal to R times T. So J really stands for job, R is, the rate, and this is the time. Now, usually in these problems, you don't really know anything about the rate, so you're going to solve for the rate. You're going to get it by itself by dividing both sides by t. That's how we get this equation right here. And that's the equation we're really going to use. So we're really adding the rates together to get the combined rate. And I'll kind of explain more about that when we get there. And then we multiply every numerator by the common denominator, just like how we did when we were solving these rational equations. And then you solve. So we have Jack and Jill. They're together they can solve 40 problems in an hour. So 40 problems would be the job. So 40 over, and we talk about an hour here, which would kind of be 1, but we also talk about minutes here. So I'm going to say that instead of being 1, an hour is going to be 60, because there's 60 minutes in an hour. So this is going to be 40 over 60 equals. The reason I'm putting the equal sign here is because that's the combined rate. So that's, they're doing this together. And we are adding the other two rates together. So we're talking about Jill. She can solve 6 problems in 15 minutes. So 6 is the job, 15 is the time. And we're saying how much time does Jack need to solve 8 problems? So Jack is solving 8 problems, that's the job, and we don't know how much time it's taking him. That's what we're trying to find. Now I'm going to go ahead and solve this. So we've done the first 2 steps. Now I need to multiply every numerator by the common denominator. Some of you might say, but wait, I can reduce. Good idea. Let's reduce this. So 40 over 60 will reduce to 2/3. 6 over 15 I could divide both by 2, I could divide both by 3, so I'm going to get 2 over 5. And now I'm going to go ahead and multiply every numerator by my common denominator. So my common denominator is 3 times 5 times x, so it's 15x. So times 15x times 15x times 15x. So we're going to cancel out the 3 and the 15. I'm going to be left with a 5 on the top. 5 and 15, so I'm left with a 3 on the top, and the x's will also cancel out. So I have 2 times 5 times x, that's 10x, is equal to 6x. Plus, when I multiply those two together, I get 120. I'm going to get 4x here when I subtract 6x from both sides. And now I just get x by itself, so I divide by 4. I get that x is 30. And the units on this are minutes. So I get 30 minutes. Sometimes you will need to actually use a calculator for these. Because you'll get a decimal or something like that. But that's generally how you do the problem. I'm going to go ahead and give you your bonus question, and I will be right back with that. And here's your bonus question. So we have a problem where you have 2 people that they live 5 miles apart and they're running towards each other. This basically means, if you're not quite sure what this means that in total they run 5 miles. Okay? So they run 5 miles in total in 30 minutes. And then you kind of have Randy's rate, or you have Randy's time and the distance, and you want to find Rhonda's time when you're given her distance. Good luck.